Hey guys, hope you're doing well. Today and tomorrow we're just going to do a little bit of notes over thermochemistry. I'm really sad because thermo is one of my favorite units, but I'm also happy because that means online school is almost over and it's almost summer. Not that summer's going to be much different than life right now, but still, that means we don't have to do this anymore. If you're taking AP chemistry, thermo is extremely important, and so you'll want to make sure you actually pay attention and take some good as possible notes. Okay, we'll get started. There won't be a lot today. So first, what is thermochemistry? It's the study of energy transformations and transfers that accompany chemical and physical changes. So how does energy change in a chemical change, a chemical reaction, or a physical change like ice melting? That's a physical change. And so it's about where the energy is moving and going. There are a few definitions that you do need to know. The first one is temperature, which is going to be symbolized with a T. Temperature is a measure of the average kinetic energy that a substance has. So if something's at a high temperature, like let's say, it's at 100 degrees, that means the molecules are moving faster than something that is at 0 degrees. 0 degrees would be moving a lot slower. Next, heat. Heat is going to be symbolized by Q. That is the letter for it. And heat is the thermal energy that transfers from one object to another. So it's energy that gets transferred because there's a temperature difference between the two different objects. Like if you have a cup of coffee that's really hot, the air is not as hot. Heat energy will leave the coffee and go to the air. And so heat is energy that transfers from one object to another. Temperature just tells you the average kinetic energy that something has. And then the last one, specific heat. Specific heat, which will be symbolized with a C, is the heat that is required to raise the temperature or the amount of energy required to raise the temperature of 1 gram of a given substance by 1 degree. And so let's say something has a specific heat of 5. That means to raise 1 gram of it 1 degree Celsius, it would need 5 joules of energy, or that object would need. Something has a specific heat of 10. Then to raise 1 gram of it 1 degree Celsius, it would require 10 joules of energy. J, joule, is the unit for energy. I don't think that's in here, but you should know that as well. So the higher the specific heat, the harder it is, or the more energy is required to heat something up. Let me erase this. And then how are heat and temperature different? A lot of people mix these up. It is really confusing what the difference between them is. So heat energy is what is actually transferred. Temperature is not transferred, and heat depends on speed of the particles, number of particles, and what type they are. Temperature doesn't depend on size, type, or anything. And so the example, the temperature of a small cup of water might be the same as the temperature of a large tub of water, but the tub of water has more heat or more energy because it has more water. Just because two things are at the same temperature doesn't mean they have the same amount of total energy. Next, draw this diagram. That's why it says draw it. And this is a heating curve of water, or H2O. So draw this. I'm gonna just sit here silently for a second while you draw it. Make sure you include your axes labels. Okay, if you need longer, just pause the video and hit play because I'm going to move on. And so what does a heating curve show? It shows the state of matter a substance is in depending on the temperature. So looking at this heating curve for water, below 0 degrees Celsius, water is a solid. This diagonal line represents when it's a solid. It's a liquid between 0 and 100. This diagonal line is when it is a liquid. And then at 100 degrees Celsius and above, water is a gas. And this diagonal line represents when it's a gas. So that's what 3 of the lines are. The flat lines right here and here are known as plateaus. You know, like a plateau in geography. At the plateaus, temperature stays the same. That's why the line is flat. There's not any sort of bend in it. It is a flat line. But if I look at my x-axis, heat is still being added. That's why it's moving along the x-axis. And the heat is not changing the temperature. Instead, the heat that's being added is used to break bonds. Didn't want to highlight. So as heat is added, it's being used to break bonds between molecules, and this plateau is where phase changes occur. So this is the phase change part. You have to add heat to change from a solid to a liquid because there are bonds that hold those molecules together. In the case of water, there's hydrogen bonds between them, and so that heat energy has to be used to break the bond. And then this first plateau, going from solid to liquid, is known as fusion. Oh, I didn't want to erase that. I wanted to highlight that. Also known as melting. And then the plateau going from liquid to gas is known as vaporization, or, you know, boiling, liquid to gas. And again, these plateaus are where phase changes happen and the heat energy is used to break the bonds between the molecules. Versus in a not plateau, as heat is added, the temperature goes up. That heat becomes kinetic energy and molecules move faster. At the plateau, the heat is being used to break apart molecules. Now, really fast, refreshing, an endothermic reaction or change. Endothermic and exothermic also applies to physical changes. So endothermic absorbs energy. Exothermic changes release energy. And energy slash heat. Those words are not interchangeable, but they kind of are. And so how do we apply this to our heating curve? Well, I'm going to ask you things like when water melts, when ice melts, when water boils, is it an endo or an exothermic change? And the way you can figure it out is read through these 3 bullets and think through them. So if water is going from liquid to gas, does the temperature of the water need to increase or decrease? Well, liquid is down here below 100. Gas is over here above 100. So the temperature of the water needs to increase. So since my water's temperature is increasing, is it absorbing energy or releasing energy? The temperature needs to go up. It is absorbing energy. So thinking about endo-exo, is vaporization going from a liquid to a gas an endo or an exothermic change? It's endothermic because it requires the water to absorb energy. Let's do another one, this time from liquid to solid. So going from a liquid to a solid, does the temperature of the water need to increase or decrease? Well, liquid is 0 to 100, solid is 0 below, and it's going from liquid to solid. So the water temperature would need to decrease. Since my water's temperature is decreasing, is it going to absorb or release energy? If the temperature is going down, that means there's less kinetic energy, so energy has been released. So is, typo, liquid to solid, An endo or an exothermic change. If energy is being released, it is exothermic. And just thinking about those two questions can help you figure out what any phase change is. What's happening to the temperature? Is it going up or going down? So is it absorbing or releasing? Another easy way to remember it is whenever you're looking at a heating curve, if the phase change is going to the right on the heating curve, like it's going from a solid to a liquid, liquid to a gas, solid to a gas, it's going right. It's an endothermic change. If it's going to the left, like a gas to a liquid, or liquid to solid, gas to solid, then it is an exothermic change, and it's releasing energy. Well, sorry, I didn't need to circle that. So you're going to go to Canvas now and take a quick little quiz. It's just over these notes. It'll be worth 25 points of an other grade. It's like 5 questions. The only thing is on the quiz, I'm going to ask you about a heating curve, and it's going to have this labels. So just label your heating curve like that. Like I'm going to say, what state of matter is water in part A of the heating curve? A right here, that, it's a solid. B, liquid to solid. C, liquid, etc.